Today we study Calculus 1, Basic Integration Rules. Now look at the known formula. Sin x dx in definite integrals equals minus cosine x plus c. C is any real number. According to the formula, maybe you can get the following formula. Sin double x dx equals minus cosine double x plus c. Why? Because you think sin variable equals minus variable. Similarly meaning sin double x equals minus cosine double x. But in fact, it's wrong. Why? Can you give me some idea about the formula? Now I can give you idea. Substitution in the indefinite integrals. Look at. Let g be a differentiable function, and suppose that capital F is an antiderivative of little f. And then if u equals gx, we can get fg times g prime dx. G prime I can take in differentiable, so we can get fgx dgx. Pay attention to gx dgx. They are the same variable. According to given condition u equals gx, so we can get fu du. And another given condition, capital F is an antiderivative, so we can get capital Fu plus c. And here replace u for gx. We can get the final result. The formula is very important. Look at the concrete expression. For example, f phi x, phi prime dx. F phi is a given expression. Phi prime, sometimes you can make it up. Phi prime dx, taking in, you can get f phi d phi. If let u equals phi x means substitution becomes fu du in the indefinite integrals. If I know the antiderivative function, the question is solved. Substitution in indefinite integrals. In the expression, please pay attention to 2 points. The general principle, point 1. If u equals gx, the original indefinite integral becomes fu du. Point 2. Replace phi x for u in fu plus c. Why? Because in the beginning of our formula, the variable is x. So finally, the variable still x. Try to understand in your mind equals capital F bracket phi x plus c. How to use the formula? Now I will give you some example to show you how to apply. Look at example 1. Try to find the indefinite integral sin double x dx. How to do? Some students maybe think, okay, I have some idea. Look at sin double x d what? D double x. Because our basic formula, sin variable, d variable, they are the same variables. So I want to make up double x. X become double x. So we need time half 1. Now it's equal, doesn't change. Let double x, they are same variables. U equals double x, we can get substitution equals half sin u times du. According to basic formula, sin x dx equals minus cosine x plus c. Pay attention to, in this formula, x sin variable, d variable equals cosine variable. They are the same variable. So sin u du equals half minus cosine u plus c. Pay attention to the last step. Replace u for double x. So our final result equals minus half cosine double x plus c. Okay, this idea is good. Maybe some student ask me, can you tell me another idea for the question? Yes. Now look at method 2. Sin double x equals double sin x cosine x dx. How to do? If you can pay attention to cosine x taking in, this means what? Because sin x derivative equals cosine x. So cosine x dx taking in becomes d sin x. Maybe now you are happy. Why? Go on. 2 sin x taking in become d sin x. Okay, u d u substitution idea. You are very happy. So now, let the same variables. Let u equal sin x. We can get w du. The antiderivative function is very easy. According to the basic idea, we can get u squared plus c. Replace u for sin x. So our final result equals sin x squared plus c. Yes, the idea is still correct. Maybe another student say sin x and cosine x, the prime have another relationship. So look at method 3. Still equals double sin x cosine x. Now I want to sin x taking in the derivative become here differentiable sin x. Similar meaning equals minus cosine x squared plus c. After class, you try to finish the concrete steps by yourself. Okay, the same question, there are 3 answers. Look at the question. In the example 1, different method may be different answers. Some students may be confused. Why there are 1, 2, 3 different answers? I can tell you no. They are different forms. In fact, they are equal. Why? Now look at method 2, the answer. Sin x squared plus c1 means any real number. We can write it sin x squared minus 1 plus c1 plus 1. 1 equals sin x squared plus cosine x squared. Sin x squared together. So become minus cosine x squared. Pay attention to c1 any real number plus 1 still any real number. Give new name c2. So method 2 answer means sin x squared plus c1 like this. We can change become minus cosine x squared plus c2. c1 and c2 means any real number. So method 2, method 3, they are the same answers. Similarly meaning the 3 answers only are different forms. So now look at example 2. Try to find indefinite 1 over 3 plus double x dx. How to do? Try to look at 1 over u. This is our new variable. 3 plus double x. Try to making up double x plus c. How to do? I will give the concrete step. Pay attention to, okay? dx equals d double x. Pay attention to equals. So you should term half. They are equal. Because d any real number equals 0. So you can plus c. They are equal. So now dx become half times d3 plus double x. Now you will be very happy. If let u equals 3 plus double x, become substitution half 1 over u du. We can get the basic formula equals ln absolute value of the variable plus c. So equals half lowering absolute value of u plus c. Pay attention to the last step. Replace the u for 3 plus double x. So the final answer equals half times log absolute value of 3 plus double x plus c. Go on, look at the example 3. Try to find the indefinite integral. How to do? In our idea, we know 1 plus u squared. How to do? Okay, a squared become 1. So taking out the real number a squared, the first step becomes 1. The second term becomes x squared over a squared. Go on. X over a bracket square. Pay attention to. If this is our u, we try to becomes u. dx, how to do? Okay, dx is our differentiable. If over a, dx over a, if becomes equal, you should over a. So this equals dx. This equals dx. If let u equals x over a, the formula becomes 1 plus u squared times du. According to the answer equals arc tangent variable plus c. Pay attention to the basic formula. In x, any expression, they are the same variable. It's okay. So now x is our u, so we can write it 1 over a times arc tangent u plus c. The last step, replace u for x over a. So this is the final result. Go on, look at example 4. Try to find 1 over x squared minus 8x plus 25. Maybe you are confused. Why? There are two expressions about x. X squared, x 1 power. How to do? Do you remember the result of example 3? A squared plus a squared dx. Okay, it is known. Look at what is a squared plus variable square. Try to become a squared minus 8x. Do you remember the a squared minus 8x plus 25? 25, we can write it x squared minus 8x plus 16 plus 9. Now you are very happy. Why? We can write it x minus 4 squared plus 3 squared. Okay, become a squared plus u squared. Now the question still is solved. So try to express the steps step by step. X minus 4 squared plus 9. 9 means 3 squared. Compare the two expressions. Okay, here a equals 3. X means variable. Here x minus 4. Pay attention to the keyword substitution. So become dx minus 4 a squared plus u squared. So our answer 1 over a means 1 over 3. Arc tangent u means arc tangent u over 3. U is our x minus 4 plus c. Okay, now look at the summary. Look at first expression. Fax plus b dx. Pay attention to fu. We cannot do anything for the integral function. What we will do? Do something about differentiable x. So we can time a over a means 1 over a fu du. Okay. Now look at the second formula. If f ax to the m plus 1 power plus 2 xm power, how to do? Fu, u doesn't change. We can do something about xm power. Okay, taking in, get the same thing. Fu du. Look at the third formula. F 1 over x times x squared dx. 1 over x squared taking in become fu du times minus. Minus, we can understand minus 1. Let's look at any real number. Here equals minus 1. F log x 1 over x dx. In your mind, fu doesn't change. Okay, 1 over x taken in, so it becomes fu times du. Look at this. Maybe this you are still happy. Why? In your mind, it's very easy. Ex derivative equals itself, so you can take in. Fu doesn't change. Taking in become du. Fu du. Another, f square root of x. This term still taking in. Get this formula. Try to understand, not remember, because as you showing some questions, try to understand the formula step by step. Go on, we still have another substitution in the indefinite integrals. Look at this, okay? In the example 1, we're using this idea. F sin x, cosine x dx. Cosine we can take in, so become fu du. Similarly meaning, we can get this formula. Sin x taken in become f cosine x times minus 1. Pay attention to the signs minus. Together, f times x, secant x squared taken in becomes fu times du. Another corresponding f cotangent times cosecant x squared equals fu times du. Still pay attention to the sign minus 1. F arc sin x. 1 over square root 1 minus x squared. How to do? Still the same idea. Fu doesn't change. Try to let the term into differentiable du. Okay? Fu du. In your mind, try to remember and understand. Another equals f arc tangent x, d arc tangent x. Go on, f prime x, fx. F prime x dx taken in become du over u equals line the absolute value of fx plus c. Try to understand the formulas. Now look at the following questions. Look at question 1. Log x over x. We have studied many formulas about indefinite integral. Do you remember this formula? fu times 1 over x dx. 1 over x you can take in, so becomes fu du. This is only a special case, so we can write it. Log x 1 over x taken in become log x times d log x, means u du. It's very easy. Equals u squared over 2 plus c. So you think the formulas are very useful, so try to understand. Now look at question 2. This is our question, how to do. Maybe you think the question is very difficult. No, why? Look at the concrete steps. D log x, 1 over x taken in become d log x. So we can get the variable is our u. Try to make up u. How to do? Now look at d log x. D any real number equals 0. So we can plus 1. Means d 1 plus log x doesn't change anything. What is different? 2. So we can times 2. They are equal. If you times 2, you should times half. Half and 2 together equals 1. They are equal. Now look at the expression. 1 over u du. You are happy. Okay, they are the same variables. So we can get half log absolute value of u equals 1 plus double log x plus c. C means any real number 2. So now look at the following question. Try to find the indefinite value, indefinite expression. How to do? Do you remember the basic formula? 1 minus x squared dx. It is known equals arc sin x plus c. What is different between the two formulas? Okay, here is 1, but here is a squared. So you try to make a squared becomes 1. This is our idea. Okay, become 1. How to do? We can take a squared out. The term become 1. This term means a squared over a squared. Become 1. 1 minus, okay? So we still can taking out 1 over square root a squared means 1 over a absolute value. This means 1 over square root a squared still equals 1 over the absolute value of a. A is a given condition. A is a positive number, so equals 1 over a. So the term means 1 over a dx. dx, u is our x over a. So over a times a. Pay attention to a over a. They can delete together. Becomes 1. So become du square root 1 minus u square. You still very happy. Why? That's the same variable, same expression. Du square root 1 minus u square. du 1 minus u square. So the final result is arc sin x over a plus c. The question is still solved. The class is over. See you next time.